Hey Year 12, here we are with the first video for our new topic for exponential functions, right? Or the exponential function. We've got one special one that we're going to refer to by the definite article there, the exponential function. Anyhow, first of all, we need to revise our index laws, right? Index laws, we learned them a long time ago. We need to be pretty good at them in this topic. So, remember these sorts of things. Remember, coefficient, number out the front here. Base, this number here. Exponent or power or index is this little number raised up high there, right? Tells us how many times it's multiplied together. So if I have a to the x times a to the y, that means a being multiplied together x times and a being multiplied together y times. So altogether there are x plus y a's being multiplied together, right? Like this. Division works very similarly. Power to a power, well, if this were a 2, for example, that would be a to the x times a to the x. So that would be a to the 2x, right? A to the x to the y, a to the xy. Be careful not to confuse the coefficient and the base. So here, right, this doesn't have a coefficient, or it has a coefficient of 1, so I don't need to raise that to the power of 4. It's 5 to the 2x times 4, 5 to the 8x. Okay? Now here we have the same base. We can't multiply these together if they don't have the same base. We do have the same base, which is 3, in which case we add the exponent, so that's 3 to the 7x, right, because I add the 2x to the 5x. Now over here, again, we have the same base of 2, right, so we subtract them. 4x plus 2 minus x is 3x plus 2. Okay, be careful, we're not messing with the base there. It's all about that base. Never mind. Now, powers of powers, quotients, right, where I've got this kind of thing going on, where I've got a power outside the brackets, applies to everything inside the brackets, right, or if I've got a fraction there, I can split it up. Yeah, essentially that's what we're talking about, is splitting it up, distributing, in a way, that exponent. So this is like 3 to the 4 times 2x to the 4, which is equal to 3 to the 4, 81. 81 times 2 to the 4x. Now I can't do anything with that 81 and the 2, right? Can't do anything. It's 81 times 2 to the 4x. Right, that's it. Now, a 0 index is equal to 1, pretty much. 0 to the 0, who knows, it's complicated, don't know. But anything else, and really we see any variable to the power of 0, it equals 1. And a negative index is the same as the reciprocal of the positive. So a to the negative x is 1 over a to the x. Okay, 1 over. Very good. Now let's have a look here. Now which one is better or more correct? It depends on the question. I suppose if they give you a question, it's in one form, they want you to use the other one. Probably. So what we want to do here, we want to use a fraction instead of a negative index. No negative index means that's equivalent to 1 over 7. 1 over 7 times 1 over 5 to the x. Okay, I go 1 over and I change the sign of that exponent. Right, which equals, is it 1 over 35 to the x? No, it is 1 over 7 by 5 to the x. That's all. Can't do any more than that. Right. They don't have the same base. So 1 over 7 times 5 to the x. A fraction means a root. So 1 over 2 is the square root, 1 over 3 is the cube root, 1 over 5 is the fifth root. Okay. And we can sort of combine those things together. If you look at this rule here, we could split that up. Yeah, right. M over n is the same as 1 over n to the power of n. Right, so we can do this various ways. We can either do it like this, or we could say it's a to the m, the nth root of a to the m. That can be outside or inside here, doesn't matter. Now, 125 to the third equals the cube root, which equals 5. Not plus or minus 5, just 5. Okay. Now this one here, well look, that's okay to me. I think it looks like that, but it says to express it a different way. Surely you don't leave it. So, now the 2, there's no brackets there, so the 2 remains there. Now, I've got y to the negative, so that means that y is going to go down the bottom.